The normal range for human hearing is between 20 Hz and 20,000 Hz or 20 kilohertz. Ultrasound is whatever is above that, above 20,000 Hz. Ultrasound is used quite a bit in medicine. It's used for imaging, for example, a fetus for pregnant women. The frequencies used for that purpose are between 1 and 20 megahertz. More information about ultrasound and using it for medicinal purposes can be found here. I'm not going to go into details about that, but I'll speak about the principle here. So we have a transducer that's going to emit ultrasounds. Remember when we talked of waves, for example, in a string, and we talked of a thick string and a thin string, and we said if we start with a pulse here, once it reaches the interface, some of it is going to be reflected and some of it is going to be transmitted. The key here is whenever we have a change in media, some of the wave is going to be reflected. That's going to happen with the ultrasounds. Whenever the ultrasounds are going to meet different media, or media at which they are going to move with different wave speeds, part of the wave is going to be reflected. The wand that's being used has also a detector that will detect the reflected wave. That's usually called an echo. By comparing the echo to the original wave that was transmitted, and by using known information about the speed of the sound in tissues, then an image of the fetus or other organs can be constructed or drawn. Now, during the procedure, if you have seen it being taken, the skin is covered with a jelly. The purpose of the jelly is only to provide good contact between the skin and the transducer and eliminate reflection of waves off the skin. Of course, ultrasound uses low power to reduce the possibility of harmful effects to the fetus or the other organs. So the whole key of ultrasounds is sending ultrasounds with a transducer, detecting the echo or the reflected waves that occur whenever different tissues are met, and then knowing the speed of sound, the speed of the ultrasound in various tissues. By using all of that information, the computers can construct an image of the object being observed, the fetus or the organs.